Today we are going to study about terpenes. Terpenes are hydrocarbon compounds found in mostly in plants and in some animals. These are diverse class of secondary metabolites produced by plants. Secondary metabolites are those metabolites which are essential but not necessary for the survival. So terpenes are thought to be built up of isoprene units. So isoprene consists of 5 carbon atoms, C5H8. It has 2 double bonds. So if we have to see the structure of isoprene. This is the structure, or you can say this one is the structure, and the numbering is done in such a way: 1, 2, 3, 4, and 5. So this is the head, this is the tail. Okay, we'll go to that later. This term terpene can be extended to terpenoids. Now terpenoids are the oxygenated derivative of these hydrocarbons. Like if these terpenes are found in the form of alcohol or aldehyde or a ketonic form or a carboxylic form, then we call it as terpenoid. Now isoprene is the main unit to form the terpene. Isoprene is common name for 2-methyl buta-1,3-diene. That means it has 2 double bonds on first and third position, and it has a methyl group attached on the second carbon. So this is our isoprene unit, and this unit contains 5 carbon atom that we have already seen, C5H8. It is thermal decomposition of all the terpenoids and terpenes give isoprene as one of the product. So this suggested that all the naturally occurring terpenoids can be built up of the isoprene units, and this was called as Isoprene Rule. It was first pointed out by scientist Walash in 1887. So this gave rise to Isoprene Rule. Now this isoprene unit, I have written head and tail. The reason it has been written is different kind of bonding are possible. So these isoprene unit can combine to form a straight or branched hydrocarbon, or it can also form cyclic hydrocarbon. Okay, so in 2 ways isoprene units can be linked to form a linear terpene or to form a cyclic terpene. Okay, before we go to the classification of terpenes, we'll study Isoprene Rule. So this is the Isoprene Rule. It is like in the biogenesis of terpenes, 2 or more isoprene molecules are linked to one another. We'll see some examples in which the statement will be clear. Okay, so basically what is happening, 2 or more isoprene molecules are linked to one another. Linkage can happen in various forms, like head to head, head to tail, tail to tail. So 3 type of linkage are possible. The first linkage is 1-1 linkage or head to head linkage. In this linkage, the first carbon of one isoprene unit combines to the first carbon of second isoprene molecule. So if this kind of linking is happening, it is called 1-1 linkage. If head to tail or 1-4 linkage is happening, that means the first carbon of one isoprene unit is combining to the fourth carbon of another isoprene molecule. It is called 1-4 link or head to tail. Then comes the 4-4 linkage. If tail to tail linkage is happening. That means the fourth carbon of one molecule is combining to the fourth carbon of another isoprene molecule. It is called 4-4 linkage. Okay. So the linkage are of three types. But there are some other linkages also which are present in cyclic terpenes other than these three. Those are called cross links. What Isoprene Rule suggested was, it states that in most naturally occurring terpenes, there are no 1-1 or 4-4 links. What Isoprene Rule suggests is only 1-4 links are present in the naturally occurring terpenes. For example, if you see my green, in this case, this green colored is one isoprene unit and orange colored is the second isoprene unit, and the bond formation is between the first carbon of the one unit to the fourth carbon of another unit. That means 1-4 linkage is there. So this molecule is according to the Isoprene rule. If you see this cyclic compound limonene, in this also there is a 1-4 linkage. This is 1-4 link. This is 1-4 link and this is cross link. Third carbon is bonded to the fourth carbon of the another molecule. So this is cross link. If you see an example of retinol, this is a vitamin A. So if you see the example of retinol, you will see the bonds. Here we have 1-4 linkage. This is a cross linkage. Again 1-4 linkage. Again here 1-4 linkage. So we have 3 1-4 linkages and 1 cross link. So retinol also follows the Isoprene rule. But there are some other terpenes that do not obey the Isoprene rule. So they are called irregular terpenes. For example, carrot has a terpene called beta carotene. The orange color in the carrots is due to this beta carotene. So the structure is like this. It's not very different from retinol. If you combine, let's just remove this OH and combine these two units, you will get a beta carotene. So the orange colored are the links. Here, just like retinol, this is cross link. Here 1-4, again 1-4, again 1-4. Here we have a 4-4 link. Then again 1-4 and 1-4, cross link and 1-4. So this beta carotene is a 4-4 link. So it comes into the category of irregular terpenes. Okay. Now let's go to the classification of terpenes. Most naturally occurring terpenes have a formula C5H8(9). That means this is the formula of isoprene unit, isoprene molecule. So basically it's we can say it's a polymer of isoprene. So most natural terpenes are polymers of isoprene units. That can be said in one way. So the basic classification is based on the value of N. Alright. So if the carbon atoms are 10, that means the value of N is 2. So class is named as monoterpenes. We have seen the example of monoterpene in the Isoprene rule, myrcene, where it's a straight chain compound, two isoprene units are linked to each other by 1,4 link. So we can say mycirine is an example of monoterpene. If number of carbon atom are 15, that means 3 isoprene units are joined together, then it is named as sesquiterpenes. If 4 isoprene units are there, it is called diterpenes. We have seen the example of retinol. Retinol have 4 isoprene units, so it is called diterpenes. Similarly, if it has 5 molecules, it is called sesquiterpene. 6 triterpene. 8 tetraterpene. More than 8 polyterpenes. So this is the classification of terpenes. This is the classification for terpenes, but similarly terpenoids are also named in similar way. Terpenoids are oxidized form of terpenes. So it is written as monoterpenoids, sesquiterpenoids, diterpenoids. That way it is named. If we look at the isolation, how do we isolate terpenes or terpenoids from the plants? Now, like terpenes could be present as the hydrocarbons, or they could be present in its oxidized form. Okay, so how do we extract them? There are 4 processes by which it can be extracted: expression, steam distillation, extraction by means of volatile solvents, adsorption in purified fats. So expression or cold pressing, it means it is just squeezed. For example, you take out the oil from mustard seeds. So that process is expression or cold pressing. Without anything, you just press it and you obtain the extract. That is called expression. Okay, so the very simple method is expression, but the most commonly used method is fractional distillation using steam. That means steam distillation. What happens in this? The source, or you can say the plant, is macerated. After that, it is steam distilled. So in the concept of steam distillation is different molecules vaporize at different temperature. So all the components gets differentiated. They will be coming out from different walls. So that is steam distillation. But what happens, sometimes you have some molecule, some terpene, that gets decomposed on such a high temperature, because for steam distillation what you are doing, you are evaporizing everything. So you are applying a lot of heat. So if you have something, some terpene or some compound that decomposes under those conditions, it cannot be extracted using steam distillation. Then you will have to do some other process. For that they follow extraction by means of volatile solvent. So what they use, light petrol, and extract it as at 50 degrees Celsius. What happens, light petrol mein you put your plant, the terpenes or other molecules, not only terpene, other molecules which are also soluble in petrol will come into the petrol. Now this petrol have your desired compound. Now you have to separate that compound from the petrol. So what you do, you do not want to evaporate all the petrol. So you want it back in some ways. So what you can do, you can distill it at a reduced pressure. Like you are not providing the desired temperature at which the petrol will vaporize. Instead, what you are doing, you're providing lower temperature, but you're reducing the pressure. due to the reduced pressure, the solvent, in this case your petrol, gets evaporated. It gets evaporated lower at a lower temperature than its boiling point. So the petrol gets evaporated, that can be condensed and obtained in a separate container, and in your parent container you will have your compound, you will have your terpenoid. There may be some impurities that you will have to purify, but the process is extracting using a volatile solvent. Another alternate method is adsorption in fats. So what they do is they warm up the fat at 50 degrees Celsius and then spread the flower petal or leaves, whatever the source of the terpenoid or terpene they are taking, they spread it on the surface of the fat until the fats get saturated. जब तक फैट में saturation नहीं आता, they keep on putting the petals or the leaves, whatever the source is, and once the fat is saturated, they digest it with ethanol. So now what happens? Your terpene or terpenoids come into the ethanol, okay, and your fat mostly being insoluble stays separated, because fats are generally non-polar while ethanol is a polar substance, so they are mostly immiscible. But sometimes some fat molecules get dissolved in the ethanol. So how they separate that? They cool it down. Fat solidifies at a very low very easily. So if they cool it around 20 degrees Celsius, the fat solidifies, and then they separate the ethanol, and ethanol have your terpenes or whatever terpenoids you have separated. Now then it is also separated from ethanol. So again the separation is by distillation under reduced pressure. So basically they separate the ethanol from the terpenoids also, but the last terpenoid solution you obtained, it doesn't contain a single terpenoid. It could have different kind of terpenoids. So that depends upon your requirement. If you require the mixture of terpenoid, you can use it as it is. If you want one single terpenoid for some purpose, then you will have to again do the fractional distillation. So fractional distillation will help you out in separation of different terpenoids. Now your distilled solution could have both the things, your terpenoids as well as your terpenes. So when you do the distillation, your terpenes are separated out first, and after that the oxygenated derivative, that means terpenoids are separated out later. Why? Because terpenoids are oxygenated form. That means it might have a alcohol functional group or an aldehyde functional group or ketonic functional group. So it has a tendency to form hydrogen bond. And you know that if two molecules have similar kind of molecular weight, but one has a tendency to form a hydrogen bond, then the molecule which have a tendency to form hydrogen bond will have higher boiling point. So that is the basis of this. Due to this reason, hydrocarbons are separated out first, they are distilled first, after that the terpenoids are separated. Okay. Now this is distillation of residue under reduced pressure gives us sesquiterpenoids, and these are separated by fractional distillation. So this we have already discussed, that fractional distillation helps us in separating out different terpenoids. Now we have a very good technology. Now we have chromatography. Not one type of chromatography, but a lot of different type of chromatography. Chromatography is used both for the isolation process as well as the separation of terpenoids. Now, gas chromatography is so effective that you can separate out two different enantiomeric forms or two different conformational form of a terpenoid. When you do separation using fractional distillation or steam distillation, what happens? The two enantiomers or two conformational forms have same boiling point, so you cannot separate out them using a distillation process. So those can also be separated out by using gas chromatography. Now if we see the therapeutic use of terpenes, they could be used as antidepressant, antifungal, anti-inflammatory, gastroesophageal reflux. Gastroesophageal reflux is acid reflux. Some people say they have acidity, so that is called gastroesophageal reflux. And immune stimulant, so it can also boost your immunity. So these are the therapeutic use of terpenes.